So section 5, domain restricted graphs. We're going to take the same kind of graphing that we did last week, and we're just going to take a piece of the graph. But if I want a piece of the graph, I need a way of talking about which piece. And the way we're going to do that is with domain. We're going to say, I want the piece of the graph in the domain from here on, or from here to here. So, first off, let's just remind ourselves, domain represents the blank of the function. What part of the function, or what are we talking about when we talk about domain? X values. Perfect. The X values. Now, we're going to actually get to the rest of this in just a moment. Let's just get some practice in with graphing. I'm going to give you guys 1 or 2 minutes with pencil. If you don't have a pencil, don't do this next part, okay? Just wait for a minute. With pencil, I want you to graph on your first one, y equals negative x squared. Can everybody do that? It's a simple parent graph, quadratic, y equals negative x squared. Go ahead and try that with pencil. If you have a pen, just kind of watch somebody else for a moment. The first part here is exactly the same as what you've done before. All right, check how you did. Should you get a U-shaped graph, hitting those 5 points? Any questions about just graphing the basic graph? Okay, phones should be away, other stuff, yes. So, if the simplest way is T-chart, plug in -2 and +2. That would be fine. There are shortcuts. If you want, you can come in and talk to me about if you learn another way or if you want me to explain another way. For now, though, I'd say just if you need 2 more points, just plug them in and evaluate it. Does that make sense? So -2 squared would be +4. Is everybody clear that the negative out in front would happen after the squared? So you plug in -2, -2 times -2 would be +4. Then you make it negative, which is why the graph is upside down. Now, what we're going to do is they're going to give you one important point that they want you to state the actual point for. So they say, what's f of -1? Okay, you plug in -1. -1 squared is 1. Make it negative because of the negative out in front. And we get -1. Is everybody clear that that's this point right there? We put in -1, we get out -1. So the new piece here is this. They're saying graph f of x where x is greater than or equal to -1. Now, I've given you a little cheat sheet up here as a quick reminder about how these inequality symbols work. So if it's x is greater than, that means you're going to the right of that number. You want the bigger values. And if we're dealing with a greater than or equal to, or less than or equal to, or an equal sign, we're going to put a solid dot. Solid dot means equal to. Is everybody good with that?
Yes.
If there is no or equal to sign, we're going to put an open circle to say I don't actually have that point. So here, the way I'm going to note this, you might want to go ahead and draw this on the bottom of your graph, or I'll show you a few different ways. We're going to start at -1 for the x's, a solid dot because it's or equal to, and I'm going to go to the right of that. Those are the values that I want. Everything to the right of -1. So the method here that requires you learning the least new things is to take the graph that you already did, graph it like normal, decide where your graph's supposed to be, and erase the part of your graph that you don't need. So I don't need anything left of -1. So I'm just going to erase this piece of my graph. I'm going to erase everything to the left of -1. And then at that point, I'm going to decide, do I want a solid dot or an open circle? Well, here, solid dot is fine because we have an or equal to. I can include what's at -1. So solid dot, graph goes around and down. There is my graph of -x squared where x is greater than or equal to -1. Does that make sense to everybody? I'm just getting rid of everything less than -1. Now, finding the domain and range, you've already done that many times, but a quick reminder, the domain will always match whatever the restriction is there. It's just they're going to ask you for it. Look at the instructions here. They're going to ask you for it in interval notation. Interval notation means that instead of x is greater than or equal to -1, I'm going to say I'm going from -1 to infinity. That's my domain. It's the same thing, just stated a different way. Why did I put square brackets there? Because of the or equal to, the closed circle, square bracket at -1 to infinity. Now the range you're going to have to figure out, because the range just is whatever happens after you graph it. It's not the restriction that they gave us. What's the highest value for this? Is everybody good with that? 0? And then I'm going down to -infinity. So I'm going to list this as my range is -infinity, always parentheses for infinity and -infinity, up to 0 with a square bracket, because I have that point right there. So that is one method for graphing these. You essentially graph the whole function and then erase the piece you don't need. Totally fine. Let's try another way so that we don't have to do the extra work of graphing it and then erasing. So let's try this one. X minus 3 squared minus 2. Well, they say that the important point is going to be f of 4. So let's start with that. If I plug in 4 minus 3 squared minus 2. Okay, 4 minus 3, that's going to be 1. 1 squared is 1 still. 1 minus 2 is -1. Is everybody good with plugging in 4 and getting out -1? No questions on how we did that first piece. So now I have my important point. 4, -1. And down here we find out why it's important. It's saying that I only want x values less than 4. Notice how there's no or equal to here. So on 4, -1, I'm going to put an open circle right there. Open circle at 4, -1. And then I want all the points to the left of it, right? It's saying x is less than. So I want 3 and 2 and 1 and 0. Now, if the whole drawing a line underneath the graph isn't enough for you, if you want it to be even more obvious, you can take a highlighter or something else, some other colored pencil, pen, and draw your line right through 4. So there's my boundary. And then I want less than that. I want everything less than it. So draw arrows showing, okay, only to the left. Nothing over here. Nothing on the right-hand side. No graph on the right-hand side. Does that make sense to everybody? Again, phones away unless you're like taking pictures of the notes or doing something else here. So from there, I'm just going to put in some points that are in this section, in the left-hand piece. Now, this is a quadratic. It would be great if I knew where the vertex is. You really should find the vertex even if it isn't in the part that you're going to be graphing. So here, what's the vertex for this graph? Positive 3, negative 2. Positive 3, negative 2 is right here. That is in the part that I'm graphing. Is everybody good with that? It is in the part that I'm graphing. I can put a couple other points down as well. Maybe put in 2, I'd get out negative 1. If I put in 0, we did this in a previous class, you get negative 3 squared is 9. 9 minus 2 would be 7. We're way up here, right at the edge of the graph. So that's enough for me to say, okay, here's my U shape. Try to make it as U-shaped as possible. And here, do put an arrow at the top. Put an arrow at the top showing that we don't stop there. Are there any questions with that one? It's essentially the parabola just stopping at x equals 4. So let's get domain and range here. All right, Alex F. Where is Alex F? There you are. Okay, what would the domain be here? Okay, so we've got positive 4. Mm-hmm. That's right, but I want you to flip it. Always go with the smallest or left one first. Negative infinity to positive 4. And then, do either of those get square brackets? So, it's all parentheses. Is everybody good with that? Negative infinity always gets a parenthesis. The 4 is an open circle, so it gets a parenthesis also. Let's get somebody else for the range. Bryson. What? It is, and do either of those get square brackets? Ooh, okay. The negative 2 gets a bracket because it's actually on our graph. Does that make sense? That point right there is a solid dot. So negative 2 to infinity. All right. Oh, I want you guys to practice one, but I also, well, we'll practice one. Go ahead and do number 1 on the homework for tonight. Number 1 on the homework for tonight. If you finish number 1 quickly, you can try number 3. Number 3 is almost exactly the one we just did with one tiny, tiny little change. So you have to look very closely at number 3. Don't accidentally do the same thing we did for the notes. Please raise your hand and ask if you have questions. Okay. Let me...
Personally, I just like the erasing method. It's so easier. If you're doing it again, it's just like, you have like a weird method. It's still a little bit off.
There should be 2 L-shaped graphs. I think you have one up here, and the other one goes the other way.
I know the text.
Chris.
It's not like the joke.
see it, right? Yes, those are the correct points. And so now you're just going to decide, okay, where's your starting or stopping? Which is that? Okay. That'll be perfect. You guys, you're welcome to work together, talk with each other.
So domain and range on the first one are both 0 and then infinity with a bracket on the I see it like I got 0, 0.
Okay, so this one, if there's no pluses or minuses, the vertex is 0, 0. Does that make sense? You put in 0, you get out 0. But then you put in 1, you get out 1. Put in 2, you get out 4. You can essentially just make yourself a nice T-chart here. This one, the vertex would be a solid dot, as long as it's in the part that you're graphing. So the boundary is at -2. That's where your open circle is going to be. And that's what you started to put. You want that right there. And then you can put in -1, get out +1, 0, 0, 1, 1, 2, 4. And you'll have that U-shaped graph. It just starts right here instead of starting up at negative infinity, going that way. Because that's the point you plugged in. You plugged in -2 and got out 4. Yeah. That's correct. Okay. So yours, right now, you're going from 0 up. We want to start at -2. We want to start over here. And then, well, here. And then come down and over. Does that make sense?
Well, I thought it was like this because it said of the restricted function.
Right. This is the restriction.
Yeah, but wouldn't the restriction make it just this line?
I think of another way to phrase that. So the restriction is going to be based off of a piece of the domain. And the domain we want is -2 to infinity. Right now, you're giving me the domain of 0 to infinity. What you did here is correct, but it's not what they're asking for. So the restriction's not like positive or negative or anything like that. It's whatever they tell us. And here they tell us it's x is greater than -2. Whereas over here, it's going to be x is greater than -1. Here, it's x is greater than +1. It could be anything. It's going to be different for each one. They're going to give us what the restriction is. Does that make sense?
Yeah, so for the domain, would it be like -2 there?
Yeah, really, these are always going to match. They're going to give it to you in inequality notation and then ask you to write it in interval notation, but they should be the same thing.
Okay, I see. So I got the I got the graph though, right?
Your graph is correct.
Okay.
Just didn't extend back to here.
Oh, okay.
Does that make sense? It starts wherever the important point is that they give you. So they gave us -2. They wanted you to plug in -2. -2 squared would be 4. So that -2, 4 is your starting point. And then you're going to graph everything bigger than that. So you'll go there, there, and down and around. All right, guys, I'm going to put the answer up here. Check your work. See how you did. See how you did. A few of you, I see a few of you with the open circle here, but you still have an arrow starting there and going up. It is wrong. We need to only have the stuff to the right of -2, nothing to the left of -2. We'll talk about, there are instances where we'll have things like that, but it's not what we want just yet. Because again, this says only x is greater than -2. So only things bigger than -2. All right, back to the notes. Back to the notes. Negative 2 times x plus 3. So here with straight lines, you guys, with straight lines, it's probably fastest just to graph the whole thing and then erase the part you don't need. Negative 2x plus 3 would start at 0, 1, 2, 3. There's my y-intercept at positive 3. Nothing wrong with making a t-chart and just plugging numbers in. But then we're going down 2 over 1, down 2 over 1. Or again, just plug these points into your function and get the y values. So those are all the points that I would get if I was just graphing this line like normal. So there's the graph. If you did it with pencil, please don't do this with pen or else you're going to have a little bit of an issue. Then decide, okay, I want x is less than or equal to 2. Here is x equals 2, right? That point right there, 2, negative 1. And again, they're going to ask you about that point. They're going to ask you to find it. When you plug in 2, negative 2 times 2 is negative 4. Plus 3 is negative 1. They're going to have you find the important point. It's right here. And it says only graph x is less than or equal to 2. So here is x equals 2. I want less than that. Okay, everyone listen very closely. I want x's less than that. I don't care about y's. I want x's less than that. So I'm going to go to the left of that point, and I'm going to erase everything that's to the right. That point itself, since it's less than or equal to, I can keep as a solid dot. There's my graph. It stops or starts, depending on how you want to think of it, at positive 2, and I only have values to the left of that. All right, the next one. This is the one that we have the most trouble with, you guys. Exponentials. We're still having trouble with exponentials. So I'm going to graph the whole thing like I just did, and then I'm going to erase the part I don't need. But maybe, if it helps you, I'll go ahead and draw where I know my graph's going to end up being, okay? So this one says x is greater than 1. Well, here's x equals 1. That's going to be my boundary line. And I only want x's greater than that. So this is where my graph should end up being. Does that make sense to everybody? Only x's greater than 1. So let's put a few points down. If I put in 0, 3 to the 0 power would be 1. 1 minus 4 would be negative 3. Again, mark these marks with pencil, because notice how that mark shouldn't be on my graph, right? It's to the left of my line. Then, if I put in 1, that's the important point. That's the one they wanted me to plug in. 3 to the first power minus 4. Well, that's just 3 minus 4 is negative 1. Now, I could make a solid dot, or I could check, oh, it's on the line. It doesn't say or equal to. This is going to be an open circle right there on the line. Open circle. And then let's put in 2. 3 squared would be 9. 9 minus 4 would be 5. 5 right there. Now, on the homework, there is one problem that asks you about negative exponents. It only comes up once, but I'm going to remind you how this works really fast. We're going to spend a whole unit doing things like this later on, but you should know how to do it. What if I wanted to plug in negative 2 here? 3 to the negative 2 power minus 4. What is 3 to the negative 2 power? There's a couple of you that remember doing this from the last couple of years, but most of us, we don't use it enough, we don't remember it. 3 squared would be 9, correct? 3 to the negative 2 power then is the reciprocal, 1 over 9 minus 4. 1 over 9, which would equal negative 3 and 8/9, so like negative 3.9, something like that. About negative 3.9. It's like maybe negative 3.8 something, 8.9, somewhere in there. So we're just above, the asymptote would have been at negative 4, and then this point would be just above that. So we'd have that L-shaped graph going up, hitting there, but the only piece I want starts at that open circle and then goes up from there, like that. It's going to look pretty much like a straight line. Try to make it curved if you can. And then erase any points that were to the left of that line. There's our graph. All right. Try on the homework. I'm going to give you the problem that causes so many issues. Everybody look at number 7 on the homework. Number 7 on the homework. Does everybody see how they want you to start at negative 2? But when you put that in, it's 2 to the negative 2 power. What did we just say that becomes? So you do the 2 squared, that's 4, and then the reciprocal would be 1 over 4. All right? Graph that as best as you can. CART students, if you need to take off, you can. I'm just going to point out 2 things. If they give you a restriction that says x cannot equal a number, graph the whole graph, find that one point, erase it, and put an open circle. Just skip over that one point. If they say x equals a number, find that one point and erase everything else. Everything on both sides of that one point. Does that make sense to everybody? Okay. So, CART students, if you need to go, the homework is 1 through 9. Number 5 is tricky. We will cover it tomorrow, okay, if you need to. But if you want to try number 5, go for it. But CART, if you need to head out, you can't. The rest of us, try number 7 here. We'll go over it, and then I'll show you some examples of that weird stuff that I was just mentioning. Please raise your hand if you have questions. Okay, so you need a copy also. All right. Hang out for one moment and I'll print it for you. Should be real fast. I know I've got more copies here somewhere. I'm just not sure where I might
Yeah, that's what because like
Oh, no, those.
eating like
There you go. Those, I won't. Yes. All right, let's go over this. I'm seeing some good stuff. Check your work. Check your work. Remember, when you put that -2 in, that's the one that I was talking about. This is where we got so many issues. 2 to the -2 power would be -1/4, or sorry, +1/4, which is right there. If you did -1, you'd get +1/2. And then put in 0, you get out 1. Put in 1, you get out 2. Put in 2, you get out 4. And you get that distinctive L shape. So, with this one, again, the domain is -2 to infinity. Matches this. This guy, it's the only time this happens on the homework. Which is why I want to do it right now. So we could get the hard, weird one out of the way. This 1/4 is our lowest value. Does that make sense to everybody? That's the lowest point here, so our range is 1/4 to infinity. I am 95% sure, I will double check on the test that that does not come up. If it does, it's like one time, but I'm pretty sure it doesn't come up at all on the test. I will double check. Most of them should be nice whole numbers. Because again, we'll spend a whole unit practicing that later on. We'll get to those. But for now, they expect you to know it, but they're going to focus more on just whole numbers, nice things to graph. Any questions with that one? Yes.
So, in order to find the other constant, just plug it.
Yeah, plug in 0, 2 to the 0 power is 1. Plug in 1, 2 to the first power is 2. Plug in 3, 2. Plug in 2, 2 to the second power is 4. Just like normal. And again, you could graph this like normal, and then just erase everything less than -2. Does that make sense? All right, back to the notes. Let's look at a couple of those weird. Actually, I'm going to go ahead and stop the recording.